Okay. So, debates about metric versus standard aside. Metric is clearly better. Let's talk about the tangent function for a second. So, I just need you guys to remember a couple things about the tangent function, so here they are, right? Okay, good. The tangent of an angle theta, right? You should be thinking TOA, right?
I always think TOA.
That's not how you spell TOA. TOA is spelled T-O-A, right? So you should really be thinking tangent is the opposite over the adjacent. Yes?
Or just sine over cosine.
Perfect. Or sine of theta over cosine of theta.
That's how we do ratio of ratios.
Yeah, which is a ratio of ratios, and that h is onesie out. You guys all cool with this? You remember this? Okay. I do not care which thing you use. They are the same. The other thing you might want to know is that thing about the unit circle. So here's a unit circle, right? Here's an angle theta. Where do you get the tangent from?
The line only hitting the circle.
Yeah, you make the tangent line over here, right, which just glances that circle. And then you what?
You continue the angle line.
Continue this up till it hits, and that length there is tangent of theta. You guys cool with that?
You can find degree or like the degrees of an arc, like can you?
The what now?
Like, can you find a degree of the arc length, or is it just mirrored with theta? Like is theta the angle arc?
Yeah, theta's the angle. Oh, you mean can I find this distance using this thing? No, it's probably better to use that S as R theta thing for that. You guys okay with this? Okay. How would I find the tangent of theta? One, you could get out a ruler and approximate, right? I would probably advise that you find the sine and the cosine and divide, or that you draw a triangle you know and read off the opposite over the adjacent. Cool? For instance, something like, okay, if I want to do tangent of pi over 3, how would I do this?
30, 60, 90.
Yeah. So this is a 60-degree angle, right? So I'm going to bust out a 30, 60, 90 triangle, which looks something like this. 60, 30, oh, I'm working in radians, so let me make that pi over 3, pi over 6, and 90. And then what are your side lengths on this sucker?
You got 2 for the hypotenuse, 1 for the short end, and root 3 for the angle.
Perfect. 1, 2, and root 3. Cool. And so tangent of pi over 3 then is, make sure you're standing at the right angle. Make sure you're standing at the correct angle. And then get your opposite over your adjacent. So this thing will be square root of 3 over 1. Alternatively, you could calculate the sine and the cosine, right? You guys see that? So if you did the sine over cosine way, what would you get? What's the sine of pi over 3? So you'd stand here, you need the opposite over the hypotenuse. So you get square root of 3 over 2. And then for the cosine, you get 1 over 2. So you need to take your square root of 3 over 2 and multiply by 2 over 1 and get the same thing. Does that answer your question about how to calculate? More or less? Cool? All right. So what else do I want you to know? I would like you to know what the tangent function looks like. So let's see if we can lay our hands on a graph for this thing.
That's the zebra thing, right?
Oh, this is the zebra thing. Cool. You guys already know.
Yeah.
Okay. Cool. So if we want to get the zebra thing,
It's at 90 degrees with asymptotes. Or pi over 2.
Yeah.
yeah. Okay. So the thing I need to remember about the zebra thing is it looks basically like cubics, but they're smushed, right? And they have vertical asymptotes. So Then I need to know where are the vertical asymptotes and where do the cubic things pass through.
They go at
Pass
90
through 0
asymptotes at
and
90 degrees.
Okay, so why are the asymptotes at 90 degrees or minus 90 degrees?
Because then the radius would be parallel with the tangent line and it would never touch it, so.
Cool, perfect. You guys see that? As I change this angle more towards 90 degrees, right? How long this hit gets is gonna get longer and longer. And then when I get here to 90 degrees, it's not gonna hit. That's not gonna be defined at all. You guys see that? Okay, so I have a vertical asymptote on both sides at minus pi over 2 and positive pi over 2. So I know it kind of looks like going up there and going down here. You guys see those? And then, yeah, it looks kind of like a cubic. Where does it go through at 0, 0, or at 0 rather? 0, 0, right? Is that 0 at angle 0, right? This length is 0. Or sine is 0 when theta is 0. You guys see that? Okay, so I get some kind of thing that looks like this. Cool? Kind of zebra-ish?
Yeah,
Why am I calling it a zebra? I have one
Because it
freaking stripe.
continues
because it
forever.
continues, you can keep on going around in a circle.
Good, good. So, does this next one flip over? Does the
No.
next one look like that?
It goes the same.
No, it goes the same way.
Yeah. Another way, if you want to see why there's asymptotes, when cosine is 0, so the 90 degrees goes up, then you can't divide by a negative. So that doesn't work.
What? Wait, no. You can't divide by a...
So you can't divide by 0, I'm sorry. I
Thank you.
said that.
Perfect. It was because I was getting excited. Yeah, so that's perfect. That's exactly my next question is, can we see the asymptotes out of sine over cosine? And yeah, we sure can. When you get to 90 degrees, cosine 0, you can't divide by 0, so something weird goes on there. Do you guys remember that about asymptotes? They come from where you have a number over 0.
Yeah.
And at 90 degrees, sine is 1, cosine is 0, so you have 1 over 0. That causes that vertical asymptote. You guys cool with that? So, continue your zebra stripes. Yeah, and notice this thing's going to fail the horizontal line test. You guys see that? So arctangent is one of those things that you should be worried about, right? Because it's not really a full inverse. It's just a partial inverse, just like the other trig inverses. They're all almost an inverse.
Period line is, okay?
What's that?
Like they're dependent on the period.
Yeah, they're made by cutting this thing into a piece. So if we were going to cut this thing to make the inverse, we'd cut
Everything that way.
this part off, and we'd cut that part off, and we'd just be left with this middle guy. You guys see that? Okay, cool. That's what I want you to know about tangent for right now. The usual shifting rules apply. They will change where the asymptotes appear. You guys see that?
Yeah.
Hang on, let me rephrase that. Just quick. Which shifting rules will change where the asymptotes appear? Yeah, so like
left and right
Horizontal
shifts.
shift.
left and right shift will change the position to the asymptotes, but it won't change how far apart they are, right?
Yeah.
We'll just slide them.
Yeah.
Horizontal stretch and compression,
Will.
yeah, that'll mess everything up, so you'll have to be careful with those. How about vertical stretch or compression? Yeah, that won't matter at all because the vertical asymptotes, right? They're vertical lines.
Anything vertical won't really mess with it.
Yeah, and the vertical shifts
No.
also won't change it. Vertical flips
No.
No.
also won't change it. Horizontal flips?
Yeah. No.
No.
Because they're the
No.
same distance.
Oh, that's right.
You guys see that?
I feel like y over x. But
Yeah, so if I flip this way, right? It
Just-
changes the picture, but it doesn't change where the vertical asymptotes are. You guys see that? How about, is tangent even or odd?
It's,
Both.
No, zero's only the only one that's both.
Neither.
I was just.
No. Good guess.
Flip it like.
Neither is actually a really good guess there, right? Because if you pull a function out of a barrel, it's not even or odd.
It's odd.
So I'm asking, is a horizontal flip, right,
Oh,
the same as the original, or is it the same as a vertical flip?
it's the same as a
You guys see that? So this one's odd because a vertical flip and a horizontal flip do the same thing.
That's weird.
Yeah, that's weird. You can actually see it from this. One of the homework exercises is to use this and notice that this thing should be off. Cool? Question, Steele?
Then it becomes not odd if you shift it up or down a little bit, right?
Yeah, if you fiddle it around, it probably won't be even or odd. Yeah, it'll probably be neither.
Can you see that from
Cool.
just that fraction? Whether it's even or odd?
Yes. That's one of the homework problems. Try it for a minute and then I'll tell you.
Okay.